Hello, everybody. We're starting Cambridge International ASN A-Level 9709, October, November 2025, Paper 1, Variant 2. Do not watch if you're here just to watch. If you're here just to, it's not a movie. If you watch me do it, you will feel smart, but you won't actually be smart. Okay, so to make the most out of this video, to make sure that you're getting the learning that actually sticks, take every question, read it carefully, twice or thrice, try it by yourself, struggle with it, maybe even get it wrong, maybe fail, and come back and see what you missed. Because I just want to make sure that if you're watching this video, you don't kind of get it, but you take away the learning that actually sticks. Let's start. Question number one, I think. Here we are. Express 9x squared minus 36x plus 8 in the form of p x plus q whole squared plus r. Now, if you notice, this is the question that we did in the class about completing the square, right? So first things first, I see no coefficient with x. So the first thing I will do is I'll take away the coefficient. So if I were to take away 9, I'll be left with 9x squared minus 36 divided by 9 plus 8 divided by 9, which will be x squared minus 4x plus 8 divided by 9. Now, when we're doing completing the square, we'll take a look at the middle term, which is 4. I'll split the middle term in half, and I'll add and subtract its square. So 9x squared minus 4x. I'll split. So if you split 4, you're going to get a 2. So I'll add 2 squared. Actually, use a different color for this. Plus 2 squared minus 2 squared and plus 8 over 9. Right. I hope you can already tell that this is a complete square. So I'll pack it into a square, which will be x minus 2 whole squared, and that is going to be negative is 4 plus 8 over 9. I am now going to multiply this 9 inside the bracket, which is going to be 9 times x minus 2 whole squared minus 9 times 4 is 36 plus I have 8 over 9. If I were to multiply it by 9, what's going to happen is this 9 will cancel out, and I'll be just left with 9 times x minus 2 whole squared. Negative 36 plus 8, which is going to be negative 28. And that is my answer. Okay. You can compare it against this. So what I wanted to express it as p times x plus q whole squared plus r. So I hope you can see the similarities. So r is negative 28, q is negative 2, and p is 9. Next, find the set of values of the constant. So look for the keywords. If it says find the set of values, which already tells me that I'm going to get an inequality, right? Because equality means fixed value. If I were to say x equals 5, x is just 5. But if I were to say x is greater than 5, which means I mean all the values of x greater than 5. It could be 5, 6, 7, 8, and so on. Right? So find the set of values of the constant k for which this has no real roots. So if something has no real roots, we remember the discriminant is less than 0, which means the discriminant is negative. So if I'll write it, I'll rearrange it actually in the first step. So that is going to be 9x squared minus 36x plus 8 minus k equals 0. So this is going to be the A. This is going to be negative 36 is going to be B, and C is 8 minus K will be C. So let's do B squared minus 4AC less than 0, which is going to give me negative 36 squared, negative 4 times A is 9, and C is 8 minus K. all of it is less than 0, which is going to give me negative 36 squared is going to be 1296 minus 9 times 4 is 36 times 8 minus k is less than 0. 1296, if I were to multiply 36 by 8, I am going to get negative 288 plus 36k less than 0. 1296 minus 288, that's going to give me 1008 plus 3k less than 0. If I were to move it to the other side, that's going to be negative 1008, and that's going to give me negative 1008 divided by 3, which is negative 24. And I'll have negative 28, actually, negative 28 as my answer. I hope it makes sense. And this is simple solving and inequalities. Find the exact roots of the equation 9x squared minus 36x plus 8 equals negative 15. This is pretty simple. When we say exact roots, what we actually mean is we'll use a quadratic formula, right? Or you can use factorization as well if you want. 9x squared minus 36x plus 8. First, I'll bring 15 to the other side. So that will be, altogether, I'm going to get 9x squared minus 36x, 8 plus 15 is 23 equals 0. I could just put it in the quadratic formula. So we know that x equals negative b plus minus. Make sure that you're not using a calculator over here. Make sure that you are um, doing the proper maths. 2 times a. X equals 9, a is a, negative 36 over here is b, and 20, positive 23 is c, right? So negative b would be positive 36 plus minus b squared would mean negative 36 squared minus 4, a would be 9 and c would be 23. All right, let's do the maths. 2 times 9 would be 18. Now I will do all of it in the calculator. So if I were to do that, I'm gonna get positive 36 plus minus. If I were to put all of it in the calculator, I'm going to get 6 square root 13. You can do this in the you can try this in the calculator. 13 divided by 18, right? Is there something I can factor out as common? I can see that I can factor out 6 as common. So 6, and this is going to be just square root 13 over 18. And if I were to do the cancellation, 6 times 1, 6 times 3 is 18. And I got two values of x, which is over 3. That is my answer. There is just quadratic equation. I think in O levels, even in O level students can do it, or an IGCSE student can do it as well. Find the term independent of x in the expansion. So we have this expansion, and when we say the term independent of x, what we really mean is a term that is x to the power of 0, right? Now, I'm not going to open the entire expansion because this is going to be too big of a task. I'll use the formula for a general term. You can find this formula in your formula sheet. T r plus 1 and r a times n minus r b to the power of r. You can find this formula in the formula sheet. T to the power of r plus 1 equals, I don't know the value of r. Okay, so I'll just simply put whatever I have. 6 is going to be the n because that's the index. So 6r, and a is 2x squared. I'm going to put 6 minus r on top of it. And negative 3 over x is the next term, and that is going to be just r, right? Now, I'm not interested in solving the entire thing. I'm not interested in it. What I am interested is just this this, this, and its power. Okay, so let me isolate this before I uh, can I say it's 2 times 6 minus r? It's actually x squared. X squared to the power 6 minus r, and negative 3 to the power of r, and x to the power of r. This is what I'm interested in, right? X squared to the power 6 minus r divided by x to the power of r, and all of it should be equal to x to the power of 0, because that's what we're looking for. We want to find out the value of r for which the x has an exponent of 0. Okay, and we'll solve it to work out the value of r. Let's do it. So that is going to be, if I were to multiply 2, that's going to be 12 minus 2r over x to the power of r equals x to the power of 0, which is going to be, by using laws of exponents, this 2 was previously, this r was previously positive. If I bring it upstairs, I call it upstairs, it becomes negative x to the power of 0. Let's solve it. So if powers are the same, I can equate the exponents, which means this entire thing should be equal to 0. And that's going to give me the value of r. 12 minus negative 2r, negative r is going to be negative 3r equals 0. 3r equals 12. And that's going to give me the value of r, 12 over 3, which is 4. I got r is 4. We're not done. I'll put the value of r to find out, because we want to find out the term independent of x, right? So I'll put the value of r in this equation. So wherever you see r, put 4. T to the power r plus 1 equals 6. 6, 4. This is just a combination you can put in your calculator and get the answer for it. 2 times 6 minus 4, x squared times 6 minus 4, negative 3 times 4 divided by x to the power of 4. So I hope you noticed that I have what I actually did over here was uh, wherever I saw r, I've put a 4. So that's, instead of r plus 1, this is going to be 4 plus 1. Right? So if you can see that r, instead of r, we have a 4. Okay, now I'll solve it, and this is going to be really easy now. T to the power of 5, from which you can tell this is going to be fifth term of the expression 6c4. If you put this in a calculator, you're going to get a 15. 15 to the power 6 minus 4 is just squared. X squared. 6 minus 4 is just squared. Negative 3 to the power of 4 is 81, and that is x to the power of 4. 5 is equal to 15. 2 squared is 4. That is x to the power of 4. 81 over x to the power of 4. I hope you can see something canceling out. They'll cancel out. And if I'll just multiply all of these numbers, 15, 4, and 81, and I am going to get my answer, which is the fifth term of the expression, and that is going to be 4860. I hope it makes sense, right? Whenever you're done with a question, pause and reflect. Always a good idea, right? Uh, Pause and reflect and notice what you did. So what we did over here was we needed to find the term independent of x, right? I used the formula for the general term. I did not know r, but I was given everything else. So whatever I could find from the expression, I've put it in there. Now I wanted to find the term independent of x, which means whatever the powers of x, all of them should be equal to 0. That gave me the value of r. Once I put in r in the actual formula of the general term, I got the value. I got my answer, which is the fifth term of the expansion that has no x, independent of x. Right, next. The graph of y equals f of x is transformed to the graph y equals f of x f 3x plus 2. Describe fully two transformations which have been combined to give the resultant graph. I'll give you overview of the transformations. I hope you remember that let's say our parent function is f of x, right? If we were to do f of x plus a, it means a units up. If we do f of x minus a, it means a units down, right? If we were to do minus f of x, that is a reflection about x-axis, right? I hope you remember that. This is y equals x squared, but if I want a reflection over the x-axis, that is going to be minus x squared, right? So there's a reflection in the x-axis, sorry, not in the y-axis. But if you have f of negative inside the bracket, that is going to be a reflection about y-axis. Okay. And if you have f of ax, um, if you have a times f of x, that is a vertical stretch by a scale factor of a. Okay, by vertical stretch, I mean stretching in the y direction. But if you have this f of ax, which means first of all a horizontal stretch, and then scale factor inverts. So if you have by a scale factor of 1 over a. Okay, so two things. Instead of vertical, now you have a horizontal stretch, and not by a scale factor of a, but a scale factor of 1 over a. And that is the stretch in the x direction. Okay, there are more, but I'll just settle for this. So I mean, by looking at this, you can already tell this plus 2 means that the graph was vertical translation, or you could just say, moved up by 2 units. That also works, right? No need for fancy words. And this 3 inside, so you remember this when you have a that is inside, which tells me that this is a horizontal stretch by a scale factor of 1 over a. So I can simply write this is a horizontal stretch by scale factor of 1 over 3. Not 3, but 1 over 3, because we're talking about the horizontal stretch. Right, that's it. This should give you the marks. A different graph has equation y equals g of x. The graph is stretched by a scale factor of 3 in the y direction. So we're talking about vertical stretch and reflected in the y-axis. Remember, when you reflect in the y-axis, you put a negative inside. So first things first, vertical stretch, this is going to be 3 outside. Because this is a reflection in the y-axis, I hope you remember, if this is a reflection in the y-axis, we put the negative inside the bracket. So I'll put a negative inside the bracket, and that's it. That's my answer. Write in the equation of the transformed graph we just did. Okay, you can also write it as, y equals 3 times g of negative x, because you can also write it as, it's fine, it works. Cool. In terms of the function g. Let's move on. Question number 4. The equation of a curve is such that dy by dx equals kx cubed plus 2 over x squared, where k is a constant. The curve is passing through the point 2s, which is 2, 20, and the gradient of the curve at s is 65 over 2. Find the value of k. Always, always a good idea to draw a graph. Always a good idea. You can draw the graph in any shape you want. Let's say this is the graph for y. Okay. I hope you remember something, that whenever I associate differentiation with one word, as a single phrase, and that is gradient of the curve, or the gradient of the tangent. You can say gradient of tangent is same thing as gradient of the curve. Okay, so let's say this is the point which is, you can randomly plot a point. Let's say this point is S and the coordinates are 2, 20. Let's say there's a tangent that is passing through it. And when I say the gradient of the tangent is 65 over 2, mt equals 65 over 2, what it essentially means that dy by dx at x equals to 2 is 65 over 2. I mean, this line really means at x equals to 2. Okay, you can not write it if it scares you too much. I think this should be enough. Right, so find the value of k. At this point, we know that dy by dx equals kx cubed plus 2 over x squared. I'll say at x equals to 2, dy by dx is the tangent of the curve, gradient of the curve, which is 65 over 2 equals, and because x equals to 2, I'll put a 2 cube. Okay. You can solve it by yourself. I'm not going to do the maths for it. You should get k, a certain value of k, and the k is going to be 4. You can solve it. It's simple. Let's move on. The coordinates, this is a 5-mark question. You have to be really careful here. The coordinates of a point T on a curve, let me draw the curve. So let's bring this curve downstairs over here. I'll make a copy of this curve. Actually, I'll drag the same curve downstairs over here. And make this line a little smaller and a little smaller. Let's say there's another point on the curve, and that point is 1, comma t, right? I need to find out the value of t. For that, I need the equation of this curve, right? Now, I hope you remember that there's y, there's dy by dx, right? Going in this direction, we differentiate, but if I want to come back to the curve, I will integrate. Okay. So to find out the value of t, of course, I need to find what the function looks like. I need to know what the function looks like so that I can put 1 in that function and I can get the value of t, which is the y coordinate. So I will, first things first, I will put in the value of, I'll start with my derivative, dy by dx, which was kx cubed plus 2 over x squared. But now I know the k is 4. So instead of k, I'll put 4. And I will integrate. So dy by dx integrates to give y. We just saw that. Dy by dx integrates to give y. And let's integrate, let's do the term by term integration. So 4x cubed dx. If I want to integrate this thing, I'll write it as x to the power negative 2, because I can do this, right? X to the power squared. If we bring it to the top, I will make it x to the power negative 2. Okay. For outside, I hope you remember the integration of the direct powers of x, which is x to the power n plus 1 divided by n plus 1 plus c. So that's going to give me 3 plus 1 divided by 3 plus 1 plus 2 stands outside, x to the power negative 2 plus 1, negative 2 plus 1. Do not forget to put a constant, that is c. Alrighty, now I have, let's simplify this a bit. So 3 plus 1 is 4. 4 will be cancelled out with a 4. As right, simplified x to the power of 4. Negative 2 plus 1 is negative 1, which will change this sign. So that is going to be negative 2. Negative 2 plus 1 is negative 1. If it goes to the denominator, it becomes positive 1. I did too many things at once, but I hope it makes sense because you're grown-up kids now. Right. I have a function. I've got y, but there's a slight hiccup. There's a slight problem. And that is, I do not know what c is. So this is a little incomplete. Okay. I could use this point to work out the value of c. Because if I were to put 2 for x and 20 for y, I'll get c. So at use 2 comma 20, which is point S. So instead of y, I'm going to put 20 equals 2 to the power of 4 minus 2 over 20 plus c. I'll let you solve it. I'm not going to solve it for you. I'm going to get the value of c, which is going to be 5. Okay, you can solve it. I would highly recommend take your time and actually solve it. Okay, now I have the function, which is x to the power of 4 minus 2 over x plus 5. I think it's easy now. We can, we need to find out the value of t, right? So at 1 comma t, for x, I'm going to put 1 and I'll get the value. For y, I'll get t. T equals 1 to the power of 4 minus 2 over 1 plus 5, and that is going to give me value of t, which is 1 minus 2 plus 5, and that is going to give me a 4. So I got the value of t. Right? Pause and reflect what we did over here. We started off with the derivative of the function. To find out the actual function, which is y, I integrated it, but integrating the function gave me an incomplete y because it had a c by the very end. Okay. So we used a point 2 comma 20 to work out the value of c, and once I had the c, my function is complete. I can put any point. If it's an incomplete point, if I know the x coordinate, I'll get the y coordinate, and that's what we did. We worked out the value of the y coordinate, which is t. I am hoping it makes sense. Next question. The equation of a curve is y equals 4x to the power of half minus x. The curve has a max point when x equals a. Now, what do we know about maximum points? We know that these are the points where the graph takes a turn. At these points, the gradient of the curve is 0. The gradient of the tangent of the curve is 0. At this point, the gradient is 0, which means if we were to calculate dy by dx at a, it's going to be a 0. We know the value of the function is y equals 4x to the power of half minus x, right? I am going to get the, I'll take the derivative of the function because a means we just saw that the gradient of the tangent is 0 at this point, right? So I'll differentiate the function, and that's going to give me dy by dx is going to be, I hope you remember differentiation of the direct powers of x, n, x, and minus 1. So it's going to be 4 would stay over here, 1 over 2, x to the power 1 over 2 minus 1, minus just x has a derivative of 1. So dy by dx is going to give me 4 divided by 2 is just 2. 1 over 2 minus 1 is just x to the power minus 1 over 2 minus 1, right? So dy by dx equals 2 over square root of x minus 1. Okay. Minus 1 over 2, it goes to the bottom, it becomes plus 1 over 2, and that turns into a square root. Now, at x equals a, we know that the gradient of the tangent is 0. Okay, so I could just write at x equals a, dy by dx equals 0. Right? So for dy by dx, I'm going to put a 0, and instead of x, I'm going to put a minus 1. Let's solve it. So a goes over to the other side. It becomes 1 equals 2 over square root a. I'm going to cross multiply. So cross multiplication will give me square root of a equals 2. If I square both sides, I am going to get a equals 4. And that's it. We got the value of a. Okay. So instead of a, I'm going to put a 4. We know that a equals 4. Next, find the exact area of the shaded region. So when we say the exact area of the shaded region, which means we'll do integration. Remember, integration gets you the area under the curve, right? So, but there's a slight hiccup here, and this is for 5 marks. So you can already expect the amount of working that we have to do here. The problem is, if I talk about the limits of my integration, I know A is 4. I do not know what B is. So to work out the value of B, I first, B is really the x-intercept, right? The root of the function. I'll have to solve this one first for when y equals 0, because this is the B is the point where y equals 0, right? This is y equals 0, y equals 1, and so on. So first things first, I will first I'll first solve the function. We know that y equals 4 x to the power of half minus x. That was the original function that I was given. I'll solve it first, right? So for x intercept, I'll try it. I'll do what I mean. I'll try it. We know that this is a, which was 4, and this is what we're looking for, b. Okay. So this is the x-intercept. We put y equals 0. Remember, for x-intercept, we put y equals 0. For y-intercept, we put x equals 0. X to the power of half minus x. I'll move x over to the other side. For x to the power of half, I'll square both sides. So that's going to give me x squared equals 4 square root of 4 is 16, just x, right? I'll just divide by x on both sides, I guess, or I could move 16x over to this side. 16x equals 0. X, if I were to take x as common, I'm going to get x minus 16 equals 0. Either x equals 0 or x equals 16. I hope you know how to do this, right? So we worked out the two intercepts. The two intercepts are either 0 and the value of b, which was turned out to be 16, right? I'm interested in 16. I'm not interested in 0. Okay. Right. Now we have the limits of our integration. I think let's integrate. So that is going to look like area, lower limit of this shaded area is 4. So I'm going to put a 4. Upper limit is 16. I'm going to put a 16. The function that we're integrating is y, which is 4x to the power of half minus x. I'll integrate this function. So I'll do the integration first and then apply the limits of integration. I hope you remember integration, which is 4 stays over here, x to the power of 1 over 2 plus 1 over 1 over 2 plus 1 minus x to the power 1 plus 1 over 1 plus 1. And I'll write the limits of integration outside of the bracket, 4 and 16. Right. 1 plus a half is 3 by 2. Right? Because of this in the denominator, once you multiply it, becomes 2 over 3, x to the power 3 over 2 minus x squared by 2. 16 and 4. Now once I'll solve it, I am going to get, you can just apply the limits of integration. 4 times 2 is going to be 8 over 3, x to the power 3 over 2 minus x squared by 2, and the limits of integration are 16 and 4. All right. Now the area is going to be first, in the first bracket, I'll put the upper limit. I hope you remember this. Upper limit minus lower limit. In the next bracket, I'm going to put the lower limit in place of x. So I'll write 8 over 3. Wherever there's x, I'll put 16 to the power 3 over 2 minus x is again 16 over 2 is squared. And I'll put a lower limit, which is 4. So 8 over 3, 4 to the power 3 over 2 minus 4 squared divided by 2. This, when I'll solve it, I should get 128 over 3. I'll let you solve it. For lower limit, if you solve it, you should get 40 over 3, which I can then simplify into area equals 88 over 3. Now, a small thing to remember, I cannot convert it into decimal. Why? Because if you go back to the question said exact area. So when they say exact area, which means no recurring decimals. Okay, and preferably in the fraction form. And we have our area, right? So let's pause and reflect what we did. We had the function, we had the function. We need to find out the area, but the problem is we did not have the limits of integration. Luckily, the limits of integration were the x-intercepts. We had 4 as our x-intercept. We worked out another x-intercept, turned out to be 16, right? We put 4 and 16 as our limits of integration. We solved it the way we solve a definite integral, and we got the area in the exact form. And that's that. Let's move on to the next question. Sketch the graph of y equals 3 sine x plus 2. I hope you remember this. This represents the amplitude. Sorry, this represents the vertical, represents the baseline, right? Baseline means my baseline. You can, I would highly recommend to use a scale to mark the points. 1, 2. I'm going to write very, very roughly, but I would recommend that you use a scale. 1, 2, 4, 6. It's going to be negative, -1, -2, -4. Okay, I'll stop here. Now, previously, the parent function is y equals sine x, right? Which we know lies, no, wait a sec, is like this, right? But because we have a +2 over here, we're going to move the baseline. The baseline of the regular parent function is 0. But first things first, I'll move the baseline upstairs. So the baseline is 2. That's the baseline I'm starting with, right? Now, 3 represents this 3 over here represents the amplitude. Okay. So amplitude means that my graph will start from here. I hope you remember the graph of the sine. I use this simple thing to remember. This is 0 degrees. This is 90 degrees. 180 degrees to 70 degrees and back to 360 degrees. And the values of sine x on these at these positions are 0, 1, 0, and -1. Okay, so at 0 degrees, it's going to be on the baseline, right? Then we'll move it 3 units up because the amplitude is 3. Okay, so at this pi by 2, which is 90 degrees, I'll move 3 units up. So my graph is going to stay between 3 units up would mean over here, and it's going to go 3 units down, so that's going to be over here. Right, I'll drag it all the way to the end. I'm going to make this line a dotted line. Right. I'm going to make this line a dotted line as well. This eraser has grown old. Anyway, so that's my dotted line and my graph is going to stay. Remember, do not get distracted by this line. Okay, this line, do not get distracted by this. And this is your middle line. Your graph is going to stay somewhere over here. Let's mark the points. So at pi by 2, it's 1, which means it's going to go up at pi by 2. It's going to come back to 0. It's going to come back to the baseline at pi. So I'm going to mark that second point over here. It's going to go down over here. And it's going to come back to the baseline at 2 pi, which I will draw over. Okay, now let's connect the points. A disclaimer, my my tablet is a little slippery, so you may not get the exact curve. And I normally struggle with drawing the exact curve. It's just about connecting the points at this point, and that's it. Okay. Do not plot a graph without drawing your boundaries in a dotted line or maybe in your head. Do not plot without marking these points. Okay, once you know exactly where to draw, where to cross the lines from, only then draw the graph. Okay, do not draw it randomly. We have that. Next, this is a particularly interesting question. Determine the number of solutions of when we say the number of solutions, we mean the points of intersection. Points of intersection of each of the following equations, right? We already drew this, right? When we say number of solutions, we have one function normally. We have one function on this side of x, and we have another function on this side, right? Let's say maybe this is f of x, let's say, and maybe the other function is g of x, right? Let's say this is g of x, right? How many solutions do they have? You can already tell they have one solution and two solutions, right? So whenever you're working out the number of solutions and there's the equation, always be on the lookout for this as your first function and this as your second function. Now, interestingly, now notice this is for 1 mark only. So this is just analysis. 3x plus 2, we've already drawn 3x plus 2. Sorry, 3 sine x plus 2, right? The other one is x. Now, x is a straight line that has a gradient 1. Okay. Normally, y equals x is this line. That is 1 is to 1, 2, it's 2. Okay, this is what a regular line looks like, which means it's going to be a line that is passing through over here. Now, when we say the number of solutions, we mean by how many points, how many times does it cut the graph? Let's see. Let's draw y equals x. A characteristic function, a characteristic of this line y equals x is that it has the same x and y coordinates. Okay, so what will be the y value when x is pi by 2, right? We know that pi by 2 is 3.141. Let's say 3.142 divided by 2. What is it going to be? 3.142, roughly 1.151 something, right? Roughly 1.5. One sec. I'm trying to run it in the calculator. 3.142. We're doing approximations here. Roughly 1.57. Okay, so let me draw a line. Let's use a red color. So if on the y-axis is going to be 1.5, 1.5 is somewhere over here, right? So the next point is going to be over here. The first point is going to be over here. This line, this is the line I'm talking about. This is the line. Now let's go back and see what we're doing. We're trying to find out the 3 sine x plus 2 equals x. We're trying to find out the number of points of intersections of these two. We already have this function. drawn right here, and we just drew ourselves a line is this. How many points of intersection are there? There is one point of intersection. I hope you can tell, right? So you would just write, given the number of solutions, you would just say one. That's all we had to write actually. Make sense? This was the graph, right? This was a straight line. So when the straight line is passing the graph only once, and this tells me that there's only one solution. Next, um, determine the number of solutions. So we have same thing on the left-hand side, but now we have 5 minus x on the other side. Okay, which means 5 minus x is a line that has a negative gradient and it starts at 5. Starts at 5 and has a negative gradient, so the line is going downwards, but the slope is 1. Slope is, by slope 1, I mean that the value of x and y are still going to be the same. Okay, so let's draw this line. Uh, the line starts at 5, so I'll take off this line. The line starts at 5. The line that I'm talking about starts at 5. This is 5. And I need one more point to draw a line. So let's take a point which has the same x and y coordinates. And that point is going to, you can take any point you want. For example, I'll take this point. At pi by 2, I'll take this point. At it's about 1.5, I'll take this point, and I'll run a line through it. So if I were to run a line through it, let's see how many times it is cutting the graph. One sec. Basically, my x and y axes are not x and y axes are not evenly spaced out, because this is a way too big of a difference compared to this. Like this is just 1.5, 1.57, while on the y axis, this much of a distance is 1.57, right? But basically, if I were to line through it, this is going to give me 3 solutions. That's the first solution. That's the second solution. That's the third solution. So this line actually has 3 solutions. A line that passes through the 3 sine x plus 2. The other line actually cuts the graph at 3 points. So we're done with this. Question number 6. Let's move on to the next question. And that is, oh, sorry, it's the same part. It's part of the same question. And it says solve the equation, right? I think we know how to do this. So 3 sine x plus 2 equals 5. I'll turn the entire equation in terms of sine. So I can write, we know that sine square x plus cos square x equals 1, which means cos square x can be written as 1 minus sine square x. So I'll write it as 1 minus sine square x minus 1. What I did was, instead of cos square x, I replaced it with 1 minus sine square x. All right, so be very careful with the domain as well. 3 sine x plus 2 equals 5 minus 5 sine square x minus 1. 5 minus 1 is 4. So that is going to be, if I were to rearrange it, 5 sine square x plus 3 sine x. That's going to be 4. Negative 4 plus 2 would be negative 2 equals 0. I got this as a quadratic equation. So if I were to solve the quadratic equation, I'll actually factorize it. 5 sine square x plus, let's break down the middle term. So if I were to break down the middle term, I am going to get plus 5 sine x minus 2 sine x. Because 5 minus 2 is 10, right? Um, 5 times negative 2 is negative 10. And how I can use that to split the middle term is 5 sine x minus 2 sine x. Now I have the two parts of this. I have this and I have the other part. Let's factorize from each one. So this is, if I were to factorize, I can factorize 5 sine x and I'll be left with, I think, sine x plus 1, right? And if I were to take out negative 2 as common, I'll be left with sine x plus 1 again equals 0. 5 sine x minus 2 times sine x plus 1 equals 0. If I were to solve the equation, that's going to give me either 5 sine x minus 2 equals 0 or sine x plus 1 equals 0, which means in this case sine x equals 2 over 5. In this case, sine x equals negative 1. Now this is settled because we already know that the value of sine, we know that it's 0 at 0 degrees, it's 1 at 90 degrees, it's negative 1 at 180 degrees, and sorry, it's 0 at 180 degrees, and it's negative 1 at 2 pi by 3, which is 270 degrees, right? So I could just write x equals 2 pi by 3, because that's the angle when sine x equals negative 1. Um, this one I'll actually have to solve. So first of all, I'll work out the basic angle and then we'll determine the quadrants. We know that it's positive, right? So according to ASTC, it's either in quadrant 1 or in quadrant 2. Okay, so either in quadrant 1 or in quadrant 2, right? Which means if I were to work out the basic angle, that is sine inverse 2 over 5. But people also call it the reference angle. Sine inverse 2 over 5, if I do that, I'm going to get 23.57 degrees. Okay. Now we said they're either in quadrant 1 or in quadrant 2. Let's see what these angles turn out to be. The actual angles or the principal angles will be in these quadrants. So this is 23.57 degrees, and this is also 23.57 degrees. Okay, let's work out the principal angles. So principal angles start from positive x-axis. This is one principal angle. The other principal angle is going to be this one, which essentially is 180 minus. So it's either 23.57 degrees or 180 minus 23.57 degrees. Okay, which is going to give me 168 point 156.4 degrees. And I can write it as 270 degrees if I'm giving my answer in degrees. It's totally up to you. You can either give your answer in degrees. So in degrees, my answer is going to be 23.57, which I can, if I'm writing in terms of 3 sig figs, that is 23.6 degrees. The next is going to be 156.4 degrees and 270 degrees. These are my answers in degrees. If you want, you can write your answers in radians as well. And that is going to be 3 pi by 2. You can work them out in radians. 391 pi over 450 and 59 pi over 450. If you want, you can work them out in radians as well. We are done with this question. Let's pause and reflect on what we did. We were given a equation We know that there was a sine, there was a cos, so I converted the entire equation in terms of sine, factorize it like we do in algebra. We got two factors. One factor gave me an angle of a quadrantal angle. These angles are called quadrantal angles. 90 degrees, 180 degrees, 270 degrees are quadrantal angles. One of the angles was a quadrantal angle, and the other one, we worked out the basic angle first and then worked out their principal angles. Question number 7. The coordinates of the points P and Q are 1, 1 and 7, 11 respectively. The line segment PQ forms the diameter of the circle. Let's draw it. So let's say this is a circle and this is the center. And we know the diameter passes through the center, right? So this is P, this is P, 1, 1, this is Q, 7, 11, passing through the center. Find the equation of the circle. We know the general form of the equation of a circle, the standard form, and that is x minus h whole squared, y minus k whole squared equals r squared, where h, k are the coordinates of the center and r is the radius. This is something we know about the equation of the circle, right? So how would I find out the center if I know the diameter? It's pretty simple, right? It's the center O would just be the midpoint, right? The ends of a diameter, the center O would just be the midpoint. So I'll use the formula for midpoint. Midpoint of PQ would be, the formula is x1 plus x2 by 2, y1 plus y2 by 2, which is going to give me, I'll do it. I'll move this a little over to this side, 1, 1. This is going to give me x1, 1 plus 7 over 2, 1 plus 11 over 2 is going to give me 8 over 2, 12 over 2 is going to give me 4, 6. That's my center, 4, 6. Okay. How to work out the radius? Well, you could just find out the distance, this distance, by using distance formula, right? So radius would be equal to, I'll just work out the distance. So the distance is going to be, well, 7 minus 4 whole squared plus 11 minus 6 whole squared. I'm using these 2 points in case you're wondering. We know the formula for distance, right? I'll write the formula. X2 minus x1 whole squared plus y2 minus y1 whole squared. I'll let you solve it. I'm going to get a distance of square root 34. I think I have everything what I need. I have the center and I have the radius, right? So let's work out the equation of the circle. We know that center is 4, 6 and radius equals square root 34. So I'll use the standard form of the equation of the circle, which is x minus h whole squared plus y minus k whole squared equals r squared. This is h and k, this is k. So x minus 4 whole squared plus y minus 6 whole squared equals square root 34 whole squared, which in the next step, the square cancels out the square root, and I am going to get whole squared equals 34, and that is the answer. I'm hoping that it makes sense. Pause and reflect. That's what we did. We were given the ends of the diameter. First things first, we found out the midpoint, because midpoint would be because diameter runs through the center, right? It has center right in the middle. So midpoint of the diameter gave me the center, right? Then I use the center, then I use the point at the end to work out the radius, because this is the radius, right? Then I use the standard form of the equation of the circle. I've put the center and the radius in there, and I got the equation of the circle. Let's move on to the next bit. Find the equation of the tangent to the circle at point Q. So let's redraw the circle. We had what we knew was there was this diameter of the circle. This is point P, and let's say this is point Q. I'm just going to draw the point Q. And the point Q is the coordinates of the point Q are, let me draw the coordinates, 7, 11. 7, 11. And we know the center of the circle is, we just worked out the center, which is 4, 6. Now, I want to work out the equation of the tangent to the circle, right? Let me draw a tangent over here. To find the equation of the tangent of any line, we need two things. We need the slope of the line, and we need a point on the line, on the tangent, right? Now, we have the point. We already have the point. The problem is, how do I know what's the slope of this line? Uh, what I can do is I can draw a radius. We know that the radius is always perpendicular to the tangent, right? So I can work out the radius first, the slope of the radius first, and I can negative reciprocal. I can do the negative reciprocal of the gradient of the radius, and I can get the gradient of the tangent, right? So gradient of the m means I'll just do m, r means the radius, and that is going to be 11 minus 6 over, you know, the formula y2 minus y1, x2 minus x1, right? So I'm using these 2 points. I'm using these 2 points. I'm doing y2 minus y1, that is going to be 11 minus 6, and divided by 7 minus 4, from which I will get 11 minus 6 would be 5, 7 minus 4 would be 3. So I'm gonna get 5 over 3 for the uh 7, 11, right? 7, 11 is the point. Yeah. I'm gonna get 5 over 3 for the gradient of the radius. Now, what will be the gradient of the tangent? Gradient of the tangent will be, of course, the negative reciprocal of that. So negative 3 over 5 will be the gradient of the tangent, right? Now, I think I'm all set. I have the gradient, I have the point, which is 7, 11. I'm going to use a slope point form. I'm sure you're familiar with this. Slope point form, which is y2 minus y1 equals mx2 minus x1. Let's put in the numbers. So y2 would be 11 minus y minus y1. I'm so sorry. Y minus y1 equals x minus x1. So y minus 11 is going to be negative 3 over 5 x plus x minus 7. Okay, I'll stop here. You can solve, we can further simplify if you want. I'll stop here. Okay, this is the equation of the tangent of the line at Q. Next, the other part, the other point of the circle with x coordinate 7 is R. So I'm going to draw the same circle, right? And we had this point Q, right? And point Q was 7, 11, right? And we already have the tangent through the point from the last question, right? Now there's another point, which is point R. Okay, because this point has the same x coordinate as Q, so I'm going to draw it right below it. That's point R. 7. I do not know what the y coordinate of this point is. I'll just say it's R. Okay. The other point on the circle with the x-coordinate 7 is r. So I named its y-coordinate as lowercase r. I do not know what it is. You can name it anything you want. You can name it p, q, anything you want. Find the coordinates of the point of intersection um, at tangent q with the tangent r. So we already have this is tangent at q, right? Let me draw another tangent, which is the tangent at r. And this is the point of intersection I am interested in. This is what I need to find out. This is the point of intersection. Point of intersection of tangents. So let's see, how do we do that? Well, first I need to know what the value of r is. Okay, because it lies on the circle, I could just simply use this equation of the circle. Equation of the circle, we know that x minus 4 whole squared plus y minus 6 whole squared equals 34. That was the equation of the circle, right? From above, of course, from here, from here, right? And the next thing we have is when I put x equals 7, see what's the value of y do I get? So 7 minus 4 whole squared plus y minus 6 whole squared equals 34. 7 minus 4 is 3, so that's 3 squared plus y minus 6 whole squared equals 34. Y minus 6 whole squared would be 34 minus 3 squared is 9, which is going to give me 25. If I square root both sides, I'm going to get y minus 6 equals 5, and I'm going to get 5 uh, plus minus 5 to be precise, right? So I'm going to get two values of y, either y equals 5 plus 6 or either equals negative 5 plus 6, which is going to give me 11 or 1. Okay. So the point R is either 7, we know the x coordinate is 7, right? Comma 11 or 7 comma 1. Now if you notice something, 7 comma 11 is already point Q, right? So it cannot be R. So the only option that's left is point 7 comma 1. Okay, so I'll take this value. Because when x is 7, y has two values. When x equals 7, y is either 11, the other value of y turns out to be 1. Right? So we found out the value of r. The point r is 7 comma 1. Right? Now I'll tell you what to do. You can pause and you can try it by yourself. I will, just like I formed an equation for tangent at q, this tangent, I already have the equation of this tangent. I will use this point to work out the equation of this tangent, right? And then I will solve both equations simultaneously to work out the point of intersection. Let's do that. So first things first, equation of tangent through R, right? For that, of course, I need the center. And we know the center is 4 comma 6. So 90 degrees, 90 degrees. Well, the center is 4 comma 6. So I'll first work, just like we did in the last question, I'll first work out uh, the gradient of the radius, and then I'll work out the gradient of this line. So gradient of radius equals, we know that r is now 7 comma 1. So I'll just say it's 7 comma 1. Gradient would be 1 minus 6 divided by 7 minus 4. I'm taking these 2 points. Keep that in mind. Right? If I work out their gradient, this gradient turns out to be negative 5 over 3. Right? So what is the gradient of the tangent? Gradient of tangent and r is going to be 3 over 5. positive 3 over 5. Okay. Now equation of the gradient of the tangent through R would be y minus y1 equals mx minus x1. This is the gradient I will pick. So I am going to get y minus, what is the point? R is 7 comma 1, right? So y minus 1 equals 3 over 5 x minus 7. That is the equation through R. Equation of tangent through R. Equation of tangent through R, right? Now I want to intersect this tangent with the tangent through Q, this line, through this line, right? I already know the equation of this line, which is over here. Y minus 11 equals negative 3 over 5x minus 7. Y minus 11 equals negative 3 over 5x minus 7. This is the equation of tangent through Q. Okay, I'll specify this in a different color. So this is through Q and through R. And we want to find out the point of intersection of these two tangents. Okay, one more time. I'll draw this tangent over here. I'll draw the other tangent over here. Let's say this is point Q, this is point R. Okay, and we have equations for both. Let's solve them simultaneously. I hope you notice something. Take a very good look at these two equations. Let me know what you notice. Here's x minus 7, here's x minus 7. If I can somehow isolate x minus 7, I can equate both equations, right? So if I were to keep x minus 7 on this side, this 5 goes over to the other side and it becomes 5 times y minus 1 divided by 3 equals x minus 7. And for this one, this is going to be 5 times y minus 11 over 3 is going to be negative. Do not forget this negative. And that is equal to x plus 7. X minus 7, my bad. X minus 7. Now I can equate both equations. Let me put this over here. So if they're both equal to x minus 1 and I'm trying to find out their point of intersection, I could just equate. I'll name these equations. Let's call this equation 1. Let's call this equation 2. And you can say equate 1 and 2. Equating means putting them together to equal to each other. So 5 times y minus 1 divided by 3 equals negative 5 times y minus 11 divided by 3, right? I'll multiply both sides by 3. You can, if it makes sense, you can just cancel out from here. Otherwise, you could multiply both sides by 3 and divide both sides by 5. So you could multiply both sides by, this is 3. 3 over 5 will be cancelled by 3 over 5. Sorry, 5 over 3 and 5 over 3. This can be cancelled by 3 over 5, right? So I could just multiply them by both sides by 3 by 5. Okay, so that leaves me 3 cancels out, 5 cancels out, 3 cancels out, and 5 cancels out. Very, very carefully, I'll be left with y minus 1 equals, there's a negative outside, make sure that you're multiplying that inside, negative y plus 11. So that's going to be y plus y equals 11 plus 1. That's going to be 3y equals 12. And from here, I'm going to get y equals 12 by 3, which is 4. Y equals 4 for the x coordinate, for the y coordinate, right? You can, sorry, y plus y, so that's going to be 2y, my bad. 2y, and of course, y 12 divided by 2, I'm going to get a 6. right? So y equals 6 is the y coordinate of the point of intersection. So if you look at the point of intersection, it's, I don't know what is the x coordinate, but the y coordinate is 6. All right. You can work out the x coordinate by putting it in any equation you want, right? Put y equals 6 in. Do you want to put it in equation 1 or equation 2? I can put this in equation 1, right? So 5 times 6 minus 1 divided by 3 equals x minus 7, which is going to be interesting. 6 minus 1 is 5. That is going to be 25 equals 3x minus 7. And from here, you can work 3x minus 21. And you can work out the value of 25 plus 21 over 3 equals x. X will be equal to 46 by 3. So the x coordinate of the point of intersection would be 46 divided by 3. Make sense? So this is the point of intersection, which is 46 by 3 comma 6. That's the point of intersection. Pause and reflect. Let's see what we did. We were given with a point on the circle, which is R. We were only given the x coordinate. To work out the y coordinate of this point, because this point lies on this circle, I simply use the circle of the equation of the circle to work out the y coordinate, which I got two values, 11 and 1. 7 comma 11 was already a different coordinate, so I picked the value of 1, and R turned out to be 7 comma 1, right? Now, because I'm interested in the point of intersection, and you cannot get point of intersection unless you have the two equations that are until you solve the two equations simultaneously, right? We already know the equation for tangent through Q. We just need to find out the equation of this tangent, right? We did it the same way as we did in the last question. We worked out just like in the last question, we worked out the gradient of the radius first. We did the same thing over here as well. Gradient of the radius, negative reciprocal to get the radius, to get the gradient of the tangent, and then tangent is passing through 7 comma 1. Hence I have the equation of the tangent through R. I already have this from the last part, which is the equation of the tangent through Q. I'll put them together, just like I did over here, and I got the value of x and y by solving them simultaneously. I hope it makes sense. First three terms of a geometric progression are a, b, and c respectively. So we know that GP, A, B over C. What do we know about GP? We know from geometric progression equals next divided by previous, right? And the first three terms of an arithmetic progression are A, B, and negative 3C. So we have an AP that is A, B, and negative 3C. And we know, what do we know about arithmetic progression? We know that there's a common difference, which is obtained by doing next minus previous. Right, show that a squared negative 10 AC plus 9C squared equals 0. If you notice, there's no B in here. There's only A and C. Okay, so let's work on GP. We know that this is GP, right? Every next divided by previous term should give you the same result because they are in geometric progression, right? So from GP, you can write from geometric progression, C over B, which is next divided by previous, should be equal to B over A. Okay, let's cross multiply. So if I were to cross multiply it, I should get B square equals CA. AC or B squared equals AC. Let me put this. BC squared equals AC. Now, we have an arithmetic progression here. You can say from arithmetic progression, what we know is next minus previous is the formula for general term, which means this next minus previous should be the same thing as this next minus previous. All right. So negative 3c negative b negative 3c negative b equals b minus a. So that's what we'll do over here. Now, if I were to rearrange this, I am going to get there's one simple substitution and we'll be done. If I were to rearrange this, b comes over to this side, a comes over to this side, and I will have negative 3c plus a equals 2b, right? Which is which will be 2b equals a minus 3c. If I were to rearrange it, I'm gonna get 2b equals a minus 3c. Let's square both sides. So this is going to be 4b squared equals a squared minus 6ac plus 9c squared, right? 4b squared, if you notice, we know that b squared equals ac, right? So I can sort of b squared, I could just write ac equals a squared minus 6ac plus 9c squared. Let's rearrange it. So this is going to be a squared minus 6ac. Negative 4ac goes over to the other side, becomes negative 4ac plus 9c squared equals 0. If I were to solve it, these two, negative 6ac, negative 4ac, I'm going to get negative 10ac plus 9c squared equals 0. And I got my answer. Okay, I know a little working. Let's stop and recap. So I think the only single thing that we did over here is next minus previous is equal to next minus previous. If you're given, if you know that it's a GP, then it's always the case that next minus previous, or in GP next divided by previous are all equal. In AP next minus previous and in GP next divided by previous are all equal to each other. Simple substitution, we got our answer. It is now given that A equals 9 and C takes the smaller of its two values. Find the sum to infinity of the geometric process. Interesting. A equals 9. Okay, what do we have from the last result? We know that a squared minus 10ac plus 9 squared equals 0, right? Instead of a, I'm going to put 9. That's going to be 9 squared minus 10 times 9 times c plus 9c squared. It's going to be 81 minus 90c plus 9c squared. And if I would take out 9 as common, I'm going to get 9 minus 10c plus c squared equals 9. And let's rearrange this. Let's divide both sides by 9 first to get rid of the 9. And let's also rearrange this equation. So if I were to rearrange the equation, I'm going to get c squared minus 10c plus 9 equals 0. 9 gets divided on the other side, becomes 0. Let's break it down. So c squared, I think, minus 9c minus c. Minus c plus 9 equals 0. C times c minus 9 minus 1 times c minus 9 equals 0, from which I'm going to get c minus 1 times c minus 9 equals 0. And from here, I'm going to get two values. Which value of c should I pick? Let's go back. Whenever you're confused, always go back to the question. C takes the smaller of its two values. Okay, smaller one is 1. I'm going to pick 1 and I'm going to discard 9. All right. Now we have the value of A, which is 9. We do not know the value of B, but we have the value of C, and that is 1. Uh, we can work out B, can't we? Because B squared equals AC, right? So from here, I can work out the value of B. B squared equals B squared equals AC. So that is going to be A is 9, C is 1. So B squared is 9. B squared is 9, B equals 3. I have all the terms. The first term of the progression is 9. It was given. We just worked out B, which is 3. We know C, which is the smaller of its value, which is 1, right? We need to find out sum to infinity. Let's work out R, because here's what GP looks like. GP is A, comma, B, comma, C, which is essentially 9, 3, 1. What pattern do you notice? Let's work out the R. Next divided by previous, which is 1 over 3. That's the value of R. The R of the geometric progression. I think we can work out the sum to infinity now. A by 1 minus R. A is 9, 1 minus 1 over 3. S8 is equal to 9. 1 minus 1 over 3 is 2 over 3, which I can write it as 3 over 2, which is 27 over 2. So sum to infinity is 27 divided by 2. That's the sum to infinity. Of course, I think it deserves 5 marks. And yeah, we had more space for the question. Somehow we did it on the same page. Right, next, find the sum of the first 20 terms of the arithmetic progression. We know that AP is A, B, negative 3C. It's given in the question. We know the values of A, B, and C. Let's put in the values of B, and C. A is 9, B is 1, C, A is 9, B is, I think, 3. A is 9, B is 3, right? And negative 3 times 1 is just negative 3. So the AP now looks like this: 9, 3, negative 3. Let's work out the common difference, which is 3 minus 9 equals negative 6 is our common difference. We need to find out the sum of the first 20 terms, n is going to be 20. We have a formula for Sn. N over 2, 2a1, n minus 1t. All right. So let's put in the formula. N is 20 by 2, 2 times a1, which is 9, plus 20 minus 1 times the difference is negative 6. Working out the formula for S20. So divided by 2 is 10. 9 times 2 is 18. 20 minus 1 is 19. 19 times negative 6. If you multiply 19 times negative 6, you're going to get 114. Right? So sum of the first 20 terms, if you do the math, you're going to get sum of negative 960. That is the sum of the first 20 terms of the series. I think it's the 3 marks are justified. I hope it makes sense. We have question number 9. Question number 9 says a function is defined by f of x equals 4 divided by 3x minus 6 squared plus 1 over 3x minus 6 cubed. Okay, one thing to notice that 3x minus 6 and 3x minus 6 is the same in the denominator. Just random thing that I noticed. For x is greater than 2. Right? Find an expression for f prime of x. So we need to take its derivative and determine whether f is an increasing function or a decreasing function or neither. Let's find out. So we know that, I think we talked about differentiation. We talked about power rule of differentiation in such a way that, let's say you have d over dx. Let's say you have a box that has a power of n. Then there are 3 steps of differentiating it. We write n, we write the box, we write n minus 1, and we write the derivative of the box. All right, so let me write down the function f of x equals 4. Can I write it this way? 3x minus 6 to the power negative 2 plus 3x minus 6 to the power negative 3, right? Now, if I were to differentiate it, then it's going to look like this. 4 would stay over here. I'll differentiate it very, very carefully. Negative 2, that's n. Box is 3x minus 6 to the power negative 2, negative 1, right? Negative 2, negative 1. And then prime, box prime, which means 3. Well, the derivative of 3x minus 6 would just be 3, right? Same thing would happen over here. Negative 3, 3x minus 6 to the power negative 3, negative 1. And the derivative of the box is just going to be 3. Let me write this carefully. So, right. 4 times negative 2 would be negative 8. Negative 8 times 3 would be negative 24 over. Negative 2, negative 1 is negative 3. If it goes into the denominator, it becomes positive 3. So you will have you'll have a positive 6. 3x minus 6 to the power of 4. Minus 3 times 3 is 9. 3x minus 6 to the power of 4. Right. So we have found out the expression for the derivative of this function. Now the next part says whether f is an increasing function. If a function is increasing, it looks like this, right? An increasing function has, the function is increasing, the f prime of x, the gradient of the tangent is positive, right? If a function is decreasing, the gradient of the function is negative throughout, is less than 0, which means it's negative and it's positive, right? Now let's analyze this because we now we have the gradient of the function, right? Let's analyze if it stays positive or negative throughout. We'll analyze it very, very carefully. Now take a look. If you carefully notice, the domain is x is greater than 2. X is greater than 2, which means whatever the values of x we're going to put in, they have to be greater than 2. So if you put in a number that is greater than 2 over here, right? So let's say you put in a number that's greater than 2, maybe you put in a 3, negative 6. 9 minus 6 is positive 3. Whatever number you put in this, I'm talking about this denominator, right? Whatever number you put in that is greater than 2, in the denominator is going to be positive. Okay, so you're going to have a positive denominator always. At the top, you have this negative 24 fixed. Like that, the value of x is not changing it. So I'll write it's negative. Minus 9 stays on top, which is positive, right? Positive. I'll say it is positive. And 3x minus 6, because it's the same thing as the last one, I'm gonna say this is 3, by the way. Is going to be positive, right? Right. So let's do some analysis. Negative or positive is negative, and negative, negative minus negative is altogether negative, which means the denominator is going, so the altogether derivative is going to be negative no matter what. So if the if the derivative is negative throughout consistently, which means the function is it is a decreasing function. Okay, this is a very important fact. We'll use it in the other parts as well. And now we've scored ourselves 4 marks. The next part says, state whether f inverse of x exists. Give your answer. If you remember, we talked about the horizontal line test and the vertical line test. Let's say we have a few functions. I'm going to draw a few functions. Right. There is a vertical line test which tells us whether a given expression is a function or not. Vertical line test tells us whether a given relation is a function or not a function. Similarly, there is this horizontal line test. Horizontal line test, which tells us whether f inverse of x exists or not. All right, so let's use this on a bunch of functions over here. If I were to do the vertical line test on it, it crosses the function only once. So it is a function. The answer is yes. F inverse exists. This as F inverse exists. If I were to do the horizontal line test, if you notice it crosses the function twice, right? At this point and this point. So if it crosses the function twice, the answer to F inverse exists is no. All right. Let's do it for this one. Is it a function? If I were to run a vertical line through it, is it a function? The answer is no. Is it a function? The answer is no. If it's not a function, there is no point of finding out its inverse. Let's talk about this one. Is it a function? Yes, of course, it's a function. It passes the vertical line test. Function? Yes. Does the inverse exist? For that, we'll have to do the horizontal line test. If I were to do the horizontal line test, notice the line crosses the function at more than more than 1 point. So f inverse exists. The answer is no. I hope it gives you an idea about the difference between the horizontal and the vertical line test. And if you notice, for the inverse to exist, if there is a turn in the function, the inverse does not exist, right? Inverse exists only if the function, let's say I'll give you another function for which the inverse exists. Let's say here's the function for which the inverse exists. Okay. Let's do horizontal line test, vertical line test on it. Yes, it is a function. If your question is, it is a function, the answer would be yes. Now let's run a different test on it. Let's run the vertical line test on it. If I were to run a vertical line test on it, sorry, horizontal line test on it, it also passes the horizontal line test, which means that if I were to ask the question, does inverse exist? The answer would be yes. Okay. So if you have a function that is forever increasing or forever decreasing, the f inverse of increasing or forever decreasing f inverse of x exists. F inverse of x does not exist only for those functions which are taking a turn. So if you have a turn, the inverse does not exist because then it will fail the vertical line test. Okay. Let's see. State whether f inverse of x exists. We already established in the last part this is a decreasing function which looks like this, right? So f inverse of x exists, yes, because the function passes the horizontal line test. That is, the function has a name. I think it's one-to-one function. One-to-one function. So if the function is one-to-one, which means you only have a single value of y for a single value of x, you have a single value of x and a single value of y, then of course the inverse exists. And this is the statement. And this is the reason. You don't have to write the reason of the statement. This answer should do. It's only for 1 mark. Next, a function g is determined by gx equals 4x minus 3 for x greater than a. Find the range of g in terms of the constant a. So 4x minus 3, of course, we know that it's a line, right? Which is the line has a slope of 4 and it starts at -3. The line starts at -3. So let's say this is your x-axis and this is -3. This is a line that has a slope of 4 and that has a y-intercept of -3. But it has a very specific range, a specific domain. It says x is greater than a. A could be any number. Let's say a is this, right? So the graph starts after a, which means the previous values of will not be taken into account. Will not take these values of x into account. These values will not be taken into account, and only the function after a will be taken into account. We need to find out the range. Range means the value of function on the y-axis. So if this is a on the graph, on the y-axis is going to be f of a, the corresponding y value, that would be f of a. Find the range. The range would be above f of a, right? Because this is the domain, right? This is my x-axis, by the way. On x-axis, you have the domain, x is greater than a, but of course the range is going to be above f of a. Right? In this case, g of a, right? So g of a will be 4a minus 3, and the domain is, we can say the g of a is greater than 4a minus 3, or you can say the range is greater than 4a minus 3, because you'll get 4a minus 3 over here. Okay, that's how we work out the domain and range of a linear function. This is interesting. Find the set of values for which the composite function f of g exists. Let me write on the both functions. Function f was, we have this function 4 over 3x minus 6 whole squared, 4 over 3x minus 6 whole, I think it was squared, plus cubed, plus 1 over the same thing, 3x minus 6, and that is a square. So 3x minus 6 squared. So 3x minus 6 squared. That's f. And g is, this is x greater than 2. By the way, the domain is x greater than 2. And g is 4x minus 2. And it has, the domain of this function is x greater than a. And we just worked out the range of this function. The range is 4a minus 3, greater than 4a minus 3. I will say y, you could say y is greater than 4a minus 3. We just worked out the range. Now, we're talking about a composite function. A composite function in such a way that you have inner function as g and outer function as f. Let me draw it. so that it makes more sense. Outer function is f and the inner function is g, right? So think about this. The range of the outer function will be the domain of the inner function. I think I should write it this way. You write the inner function first, right? Which is because we're talking about the composite function fg, right? So inner function is g of x, and the outer function is f of x, right? So if you notice, there's a certain input going into inner function, which is x greater than a. And you're getting a certain output, which is x is y is greater than 4a minus 3, right? Now, we also know that there's a certain domain to this function, and that is x greater than 2, right? So if we have two composite functions, inner function and the outer function, then remember this statement. The range of the outer function range of inner function must lie within the domain of outer function, right? In simple words, whatever is being produced by this g of x, you have to make sure that it is acceptable by f of x or not. Because whatever is being produced by g of x is directly entering into the outer function, right? There's g inside, whatever is being produced by g is directly entering into the f, right? So you have to make sure that whatever is being produced by g of x, which is the range of the inner function, should lie within the domain of the outer function, which means it should be greater than 2. So this is something that is being produced by g of x. You have to make sure that it is greater than 2. Okay. So let me write this down real quick. We has 4a minus 3. It all boils down to a single statement, and that is 4a minus 3 should be greater than 2. Make sense? So that's something I'll start with. 4a minus 3 should be greater than 2, right? If you want me to annotate it, I will, right? This is the range of g of x, right? And this is the domain of fx. So you have to make sure that they sit well with each other. So we need to find out the set of values. Whenever you see the word set of values, which means we're talking about inequality, right? These are the keywords you should know. So I have 4a minus 3 greater than 2. I think I could simply solve it. 4a greater than 2 plus 3. The solving part is not that bad. It's just 2 steps. But the understanding and modeling part is a bit trickier. 2 plus 3 is 5 divided by 4. These are the set of values of a. By set of values, I mean, well, let's say this is 5 by 4. I'm talking about all the values of a which are greater than 5 by 4. So all the values of a will be considered. You don't have to draw this. This is your answer. I would say if this part doesn't make sense, you can rewind and rewatch and try to pause and think about it. Uh, yeah, a daunting one. It looks scary, but it's actually not that scary. Interesting. You have it looks like if you ever studied biology, it looks like a diagram of an eye, a human eye. You have a retina and like this, and you have like a lens. It looks like this. Anyways, let's go to the question. The diagram shows a circle with center A and radius R. So we have two circles over here, right? If you carefully notice, we have two circles. We have a circle, a smaller circle that has a radius A, sorry, center A and radius R. This is the circle we're talking about. That's the first circle, the smaller circle. I'm going to call it the smaller circle. Then there's a bigger circle, right? And this is the bigger circle. There's the center C, and that's the bigger circle. Okay, so I hope you're able to identify the bigger circle and the smaller circle. The bigger circle has a radius of S. I hope you can see that. And the smaller circle has a radius of R. I hope you can see that. So far, so good. Uh, a larger circle of radius S has center C, passes through B and D. The length BD is also S. Show that S equals square root 3 times R. Let's do it very, very carefully. First of all, let's talk about this point A, right? I'm sure you've done this in smaller grades, and that is angle about a point, right? Angles about a point. So if you're given a certain point, and no matter how many angles are passing through that certain point, all of these angles add up to give 360 degrees. So you have A, B, that's angle C, angle D, angle E, angle F. All of these angles, A plus B plus C plus D plus E plus F, all of these angles add up to give 360 degrees, right? If you have a certain point and then you have, for example, let's say at this point there are three angles, right? Then angle A, angle B, angle C, they all should add up to give 360 degrees, right? These are called angles about a point. Take a look at this point, right? You have this angle, you have this angle, you have this angle. Each of this angle is, they all add up to give 360 degrees. So if I divide them by 3, I'm going to get 120 degrees. So each of these angles is 120 degrees. That's the first thing to start with. Cool. So I want to prove that S equals square root 3R. So I'm going to pick a side. Preferably I'll pick a triangle that has S and R. I'll pick this triangle. You can pick any of the triangle you want that has S and R. I've picked up this triangle. Okay. So this is, I hope you can already tell that this is um, because the sides are the same, this is an isosceles triangle. Right? I'm going to draw this triangle over here. Like this triangle actually looks like this. Here's a point, right? And this is what this triangle looks like. Okay. If the sides are the same, this is R, then this is isosceles triangle. Isosceles triangle says this angle and this angle will also be the same, right? So this is 120 degrees. We know that the angles of in a triangle, all the angles add up to give 180 degrees. So 120 plus x should be equal to 160 degrees. That should give me x is equal to 30 degrees. Okay, x plus x will be 2x. You do the math, you'll get 30 degrees. So this is 30 degrees and this is 30 degrees. Okay, so let's apply sine law. Right, I hope you remember sine law. A over sine A equals B over sine B. Side and its opposite angle. So you can take any set of sides you want because you know all the sides and all the angles, right? So you can take any side angle side pair you want. I'll pick this side and the opposite angle is 30 degrees. I'm going to say R divided by sine 30 degrees equals, I can take this side and the opposite angle, which will be S divided by sine 120 degrees. Let's solve it. So we know that sine 30 degrees is equal to, and sine 120 degrees. Let's work it out in the calculator. So sine 30 degrees is 1 over 2. And sine 120 degrees, let me work it out in my calc. So sine 120 degrees is square root 3 by 2. Okay, so let me cross multiply it first. This is going to be R sine 120 degrees equals S sine 30 degrees. Sine 120 is square root 3 by 2. S sine 120 30 degrees is equal to 1 over 2. If I were to simplify it, I could just multiply both sides by 2 to cancel out the 2, right? And I'll be left with s equals square root 3r. Is that what we were trying to prove? Yeah, s equals square root 3r, and we just proved this to ourselves. I hope it makes sense, right? I have a challenge for you. Take your time and give this video a pause and try doing it by cosine law. Give yourself a break and try attempting it by using the cosine law. You'll get the same answer. Okay. Um, let's do it by using the cosine law. Um, we know that cos A equals a squared plus b squared minus, sorry, cos A would be b squared plus c squared minus a squared divided by 2bc, right? So I have to apply cosine law, which means I can stand myself at any angle I want. I can stand at this angle, right? So if I'm standing at this angle, cos 120 degrees, then I'll take the sides r squared plus r squared minus the opposite side is s squared divided by 2 times r and r. And you once you work this out, you'll get the same result. Square root 3r is equal to s. Okay, so there are more than one ways of doing this question. Okay, we're done with this part. It was 2 marks. You don't have to do it by both ways. You can pick any one way to solve it, and then you can solve it. Right, let's move on to the second part, and this may be the last one. Next part of the question says, find the expression for the area of the shaded region. So this is the area of the shaded region that we're looking for. It has a moon shape. Give your answer of the form a plus b pi r squared. Right. How would we do that? We have to take into account the bigger circle and the smaller circle, right? So let's take a look at it carefully. This is the center of the smaller circle. This is the center of the bigger circle, right? And I hope you can notice these, if you see these, sorry, you see these are the sectors of there's one, there's a bigger one starting from here. This is the sector of the bigger circle. So I'm giving you a few hints. Take your time, take a pause, and let me know what should I subtract from what so that I can get this area of the shaded region. Take your time, like think about it, take a pause and um, give it a thought. So what I think is that area of shaded region is equal to, first of all, area of a smaller circle. So sorry, I'll take the entire thing as the area of the smaller circle, right? So this is the area of a smaller circle. What should I take away from it? If you carefully notice, I'll start from C. I'll make this sector. Do you notice it as the sector of a bigger circle? Bigger circle. This is C is the center of a bigger circle. This is the bigger circle. So this area being the shaded in green sector of the bigger circle, right? So that's the first thing I'll subtract from. So first thing I will have is the area of smaller circle. I will subtract from it of the area of sector. I'll name the sector CBD. Sector CBD. I think at the top I'm talking about the big circle. This is just for reference. It's just to understand. Okay, what else do I have to take away from the smaller circle? One more time. This is a smaller circle, right? I've taken away this. So I already subtracted. What else do I have to subtract? I think I have to subtract this and I have to subtract this. These are called segments. Okay. And we have two of these segments. I'll say -2 and segments of smaller circle. Okay. This is the entire thing that will give me the shaded area. Now let's talk about area of formula. I'll write the formula over here. The formula for area of a circle, you know that it's pi r squared. Area of a sector is 1/2 r squared theta, where theta is in radians. You have to make sure that your theta is in radians. And segment is interesting. Take a look. Here's a circle, right? And here's a sector, right? If I cut the sector, I'll get the segment. So if you carefully notice, isn't the entire sector of the circle is made up of a triangle plus a segment. Does that make sense? Triangle plus segment, which means if I have to find out the area of a segment, what I can do is I can just take the area of a sector and subtract the area of a triangle from it. Makes sense? I just simply rearrange the same equation. Again, sector, the entire sector. Think of it actually as a pizza slice, right? So out of a sector, if you take away the triangle, if you take away the triangle from a sector, you're just left with a segment. Okay, so these are a few things that we're looking at, and we know the area of a triangle, right? For example, if you're standing over here, if you know this angle theta, if you know this side, let's say this side is A and A, or maybe A and B, right? Then the formula of area of a triangle will be equal to 1/2 A B sine theta. Essentially, the sides, these sides, and the included angle. If you have that, you can work out the area of a triangle. So these are the formulas. These are all the formula that we'll be needing. This, and this, because we're dealing with area of a circle, area of a sector, and area of a segment. Let's do it very, very carefully. Let's call this thing as A. Let's call this thing as number B. Let's call this thing as number C, because these three things will be working out. Okay, area of a small circle. Let's work that out first. Area of a small circle. Be very careful. Area, the radius of the smaller circle is r, so that is just going to be pi r squared. Okay, we worked out A. Area of a sector CBD. Area of a sector CBD. We're talking about a bigger triangle. I'll take off a few things. Okay. This is a sector I'm talking about, right? Now, I hope you remember that in the last topic, in the last question, we worked out that this angle was 2 pi by 3, which is 120 degrees. This was 30 degrees, this was 30 degrees. If you add two 30s, you're going to get 60 degrees, which is the same thing as pi by 3. So I'm going to take this angle as pi by 3. Okay, so area of a sector, let's work out the area of a sector. Area of a sector is going to be, I'm talking about the bigger sector, half. Now, do not put R over here because I'm talking about the bigger circle, right? I'll write this a little downstairs. 1 sec. Instead of R, I'm going to put an S over here. I hate when it stops working. So 1 over 2 s squared, because s is the radius of the bigger circle, right? And theta is pi by 3. Okay. Now, if you go back to the question says give your answer in the form of a plus b pi r squared, which means there is no s in the answer. So we somehow have to find a way to convert s into r. If you take help from the last part says s equals square root 3r. If I were to square both sides, I'm going to get s squared equals 3r squared. Okay, this is something I'll use instead of s squared. I'm going to write 3r squared and pi by 3. 3 and 3 will cancel out, and I'll be just left with 3 and 3 will cancel out. I'll be just left with pi r squared by 2. Okay, so we have this. Let's very carefully work out the segment of a smaller circle. Okay, um, area of segment smaller circle. Let's work it out. So for the smaller circle, we know that it is sector minus triangle. Okay, we're talking about the smaller circle now. If you talk about the smaller circle, now I'm going to take it off. This is a smaller sector, right? This over here, you see the smaller sector, right? And which is made up of a triangle and a segment. Segment and a triangle, right? So if I want to work out the area of a sector, that is a half r squared theta 1 by 2 r squared theta, which will be 1 by 2. I'm talking about the smaller circle, so the radius is r and theta is 2 pi by 3 minus area of a triangle. I'm talking about the area of this triangle, which will be 1 by 2 r and sine, because I'm standing at this over here, this angle is 2 pi by 3, so sine 2 pi by 3. Let's simplify this a little before we put everything together. So 2 and 2 will cancel out, and I'll have pi r squared divided by 3 minus sine 2 pi by 3 is square root 3 by 2. So that's what we have so far. As far as the working is concerned, we're done. We only have to do the addition now because we're done with this one as well. Okay, we worked out the segment of the smaller circle as well. Let's put everything together, shall we? So shaded area is equal to the entire area of the smaller circle, right? The entire area of the smaller circle, which was pi r squared. Let's put this over here. Pi r squared. Okay, the first thing that I subtracted from it was area of a sector CBD, which was pi r squared by 2. I'll put this over here. Pi r squared by 2. The next thing we'll do is minus 2 times, because we have a minus 2 here. Right, we have a minus 2 here. Sorry, we have a minus 2 here. Minus 2 times segment of the smaller circle. We worked out the segment of the smaller circle, which was this. So I'll put this over here. Minus 2 times segment of the smaller circle, which is 2 pi, sorry, just pi r squared over 3. Do you want to simplify this over here? Let's simplify this a little. Pi r squared divided by 3. So that's going to be square root 3 r squared divided by 4. 4 pi r squared minus 3 square root 3 r squared divided by 12. Let's do it this way. So that makes it, turns it into a single fraction. 4 pi r squared minus 3 square root 3 r squared divided by 12. Okay, now I'm going to do this. Pi r squared minus pi r squared would be, if you were to do the maths, you are going to get pi r squared by 2 minus 2 ones are 2, 2 6 are 12. So I'll be left with 4 pi r squared minus 3 square root 3 divided by 6 r squared. Okay, let's make the denominators the same. So I'll multiply this by 6, I'll multiply this by 6. So I'm gonna get 6 pi r squared by 3. I'm so sorry. I'll multiply this by 3. These numbers are going to be 3 pi r squared and 3 multiplied by 2, from which I am going to get 3 pi r squared divided by 3 times 2 is 6 minus 4 pi r squared minus 3 square root 3 r squared divided by 6, which, because of the same denominator, I could 3 pi r squared minus 4 pi r squared plus 3 pi r squared. I'll take out r squared as a common. 3 pi r squared minus pi r squared is going to be negative pi r squared plus 3 square root 3 r squared divided by 6. Let's take r squared as common, and let's do the LCM breakdown. So if I take out, I'll be left with negative pi by 6, because r squared is out, with negative pi by 6, plus 3 pi square root 3 divided by 6, which I can further simplify into negative pi by 6 plus 3 times 1s are 3, and 3 twos are 6, so that's going to be square root 3 over 2, everything r squared. Why did I go to all of this length? Because I wanted to prove the shaded area in this form, a plus b pi, and at the end I wanted to have r squared, and that's exactly what I got. A plus b, wait a sec. A plus b pi, right? So the term with a pi should come afterwards. I'll rearrange it. I want my answer this way: a plus b pi r squared. Let's rearrange this. So if I were to rearrange this, I'm gonna get square root 3 by 2 minus pi by 6 r squared, and I'm done. Okay, so that was all of this paper. I know the last question was a bit daunting, but if you carefully look at its parts, and if you do it step by step, it's not going to be that bad. All right, that's that. Take care of yourself, and hopefully we'll see you in the next video.